Today you described some new work that you're embarking on, and I think that would be really interesting to talk about right now, because I think it is related to sickle catchers. So I wonder if you could say in a nutshell what your new research is about.
Sure. So a while back when we started developing this method that we're going to be using in sickle catchers, I was looking at older adults who were aging healthfully and looking at the role that small vessel disease in the brain might play in their cognition. And I really wanted to know, is that associated with any of the changes that we see in the brain in Alzheimer's disease? But I didn't have the capacity to do that. I also found around that same time that it looks like women develop more small vessel disease than men as they're getting older. It's also possible that women are at greater risk of Alzheimer's disease, although that's sort of disputed. But it is very likely that there are differences between men and women in the specific ways that they develop the causes of their cognitive impairment. And so I became very interested in these two things together. So my new work will put those ideas together and allow me to look at whether there are gender-sex differences in small vessel disease in the brain, and whether those are connected to amyloid and tau, the proteins that accumulate in Alzheimer's disease.
Got it. Okay. So if I understood right, there's this small vessel disease, and it sounds like you're asking a couple questions. One is, are there gender differences in small vessel disease? And is small vessel disease somehow implicated in Alzheimer's disease? So let's say, for example, women do have a higher prevalence of small vessel disease, and is that a finding that already exists?
There has been work done on that, and then I've also found that in my own work that is in progress.
Okay. So you're seeing the same thing, and then if it turns out that small vessel disease is related to a higher incidence of Alzheimer's disease, could that then be one basis for understanding the gender difference?
Right.
In Alzheimer's disease?
That's exactly what I'm curious about,
okay.
Yes.
Okay. So I think a lot of people are interested in understanding about these gender differences, and I have heard before that there is a higher prevalence of Alzheimer's in women, but I didn't know, for sure what the research was behind that. So with sickle catchers, looking at sickle cell disease, right, we're looking at the twistiness of these vessels deep in the brains of sickle cell patients and trying to see if, as Enrico was just explaining, does that give us an indication of whether or not this person's more likely to have cognitive symptoms? So how does being able to do that same kind of analysis that we're hoping to crowdsource with sickle catchers, how does it help you answer your research question?
We think that some of these processes that Enrico was talking about are parallel, and they underpin many different diseases. And there can be many causes of cognitive impairment, but sometimes the reasons for that underlying that can be the same across diseases. And so, in sickle cell disease in particular, Enrico was talking about the role of inflammation and the way that the blood vessels can be damaged by the blood cells and the factors that they secrete. It's very possible, it's very likely that inflammation plays a key role in Alzheimer's disease as well. And so you can sort of think of this aspect of this vascular inflammatory process being very related. And so if we understand how to look at the small vessels themselves very directly, historically we've had other ways to assess that damage, but it's been an indirect marker. It's been a marker of damage to the brain tissue itself rather than directly to the blood vessels. So if we develop this way that we can look directly at the blood vessels, it will be immediately cross-applicable both in sickle cell disease and in Alzheimer's disease and potentially other neurodegenerative disorders as well.
Okay, so let me see if I've got this straight. So it sounds like the sickle catchers analysis, which is looking at the 7 Tesla brain scans, will show us something about the damage or formation of the blood vessels. And I think you're saying that previously for the questions you've been asking, people have looked mostly at the brain tissue, but now if you can look at the blood vessels, that might give you a new window into understanding about these gender differences.
That's right. And not just gender differences, but many other aspects that might be going on as well. But it will give us a more direct window into the damage to the vessels themselves. The reason to focus on that, we think, is that being able to view the vessels themselves directly might put us closer to the start of the disease process. And so with what Enrico was mentioning earlier, the earlier you can intervene, the earlier you can hopefully stop this damage. So if we can see the damage earlier in the process, that would probably be useful.
That's really interesting. So it sounds like you're saying that you might be able to see vessel damage in a brain before you see damage to the brain tissue that's near that vessel.
Exactly right.
Okay. So then does that mean you could look at images of brains and brain blood vessels next to each other at different stages of disease and see which one comes first?
Hopefully we would develop that capacity. I don't think we're quite there yet. We would have to really understand what we're looking at and really, develop the process more fully. But I do think that we could get to that point, yes.
What kind of MRI data are you going to collect and from whom in order to do your research? Are you going to be looking at Alzheimer's patients?
There are participants in a study that's going on locally that evaluates the development of cognitive impairment out in the population. And so in a group of those participants, not all of them, in a subgroup of those participants who start off the study cognitively unimpaired, they will be getting this type of special vessel imaging, so 7T imaging, where we'll be able to see the small veins, and then another approach that I'm very excited about as well, where we'll be able to see the small arteries. And so some of these people will be sort of on their way to cognitive impairment, but they don't necessarily have dementia.
Enrico mentioned that the value of this kind of research from the patient standpoint is the possibility of seeing this biomarker, seeing these abnormalities in the blood vessels before there are any symptoms, and then using that to make clinical decisions to say, oh, we see this is coming down the pike, so we can do some kind of an intervention to avert that or to delay that. Is that the same way that you would anticipate using your study results, or would you use them in a different way?
It's a very similar thought process. I think that the thought of many researchers in the field of Alzheimer's disease research is that we haven't been intervening early enough in the course of the disease. And so when we do clinical trials of experimental drugs, when somebody has already been diagnosed with Alzheimer's disease and has some bad proteins accumulated in their brain, we may not be able to reverse the process at that point. And so moving earlier in the process of developing the disease would hopefully make us more effective. And as Enrico said, and the case applies here with Alzheimer's research, if you can prevent the disease from even getting started, so much the better. So I think it may also give us insight into specific factors that we know are associated with damage to the blood vessels as being really even stronger intervention points than what we already think. There is a lot of work showing that high blood pressure is bad for the small vessels in the brain. We know that that's the case also for Alzheimer's disease, but if we really show that it's directly related and that relationship is very strong, it gives us even more sort of, evidence that it's really important to control blood pressure and make sure that it stays healthy, even from earlier ages than what people typically think. So even back in midlife.
I've heard a lot of different views on how long it takes for Alzheimer's disease to go from being present, being measurable in some way in the brain to actually manifesting as symptoms. Do you have any views on that? How long do you think it takes from the beginning of Alzheimer's disease to the point where someone starts to have cognitive symptoms?
Well, we know that the proteins amyloid and tau begin accumulating, as you mentioned, long before we can sort of see the signs of that outwardly. So long before we can see that somebody's having trouble with their memory or other aspects of their thinking. Some estimates say that, amyloid is starting to accumulate even a couple of decades before we might be able to observe those symptoms. So this is why we really are starting to push the age spectrum back and say, look, we really need to, in our own studies as researchers, and then also with the advice that we give to people about taking care of their health, we really need to be pushing back to midlife and making sure people realize, that they know that even at that point, they need to be taking care of their health in a way that, I often find when I talk to my friends, people they're not clued in that way. They think, I'm still so young. I don't need to worry about that yet.
One of the findings born out of the Sickle Catchers data analysis from the Schaefer-Nischenmuller lab is that a high-fat diet is implicated in these capillary stalls. And so I wonder if you're successful in your research, does that suggest that if you had a patient who has a history of, say, high-fat diet and high blood pressure and other potential risk factors for Alzheimer's disease, who is still maybe, say in their 40s, early 40s, that you might say, given your lifestyle, we have this early marker that might suggest that we want to do something about this before it turns into something. Could you see, is that kind of like the long-term potential evolution of your work?
That's one of the ways that it could be used, yes. That people that we think are at an increased risk for a variety of reasons. Another reason, in addition to the good example that you just gave, may be that they carry a genetic risk factor for Alzheimer's disease. So, for example, the ApoE4 allele, which is related to cholesterol, we know that is the strongest genetic risk factor for late onset Alzheimer's disease, so sporadic Alzheimer's disease that you tend to develop when you're older. And so it's the type of thing where you can say, we know that somebody who has that is at risk, or we know that somebody who has had a long-standing history of high blood pressure, could be then tested with this. And we could say, okay, look, it looks like your blood vessels are not healthy, and we do need to be more particular about intervening.
This will be my last question.
Okay.
And I appreciate your time. If you discover that there is this linkage between the small vessel disease and Alzheimer's, and that could be an explanation for the gender disparity in Alzheimer's, what do you do with that information?
I think a particular interest of mine is digging into, well, why is that? So why is it that women have a greater burden of small vessel disease? Is it simply that, women tend to live longer than men? That's a possibility. So they have longer to accumulate these changes in their brain. Or are there other things that are going on that, women that are sort of like these sex-specific exposures that men may have or that women may have? So, for example, one that I have become newly interested in is, people who are able to get pregnant and have kids may be exposed to hypertensive disorders of pregnancy. Something like preeclampsia, where you develop new hypertension during the pregnancy, and it can go on to cause other organ damage, essentially. So is that possibly this sex-specific risk factor that might explain why there's more small vessel disease in women? So that would be sort of like one of the next places I would want to go. Not only would we know, hey, we need to focus maybe on women more particularly for the small vessel disease in terms of thinking that they're at risk and intervening for them, but also then we know what these specific risk factors are that they're exposed to more, and we can focus on those as well.
I see. So potentially you could say if we think preeclampsia is sort of an acute factor for small vessel disease, maybe there's an intervention for reducing blood pressure during that period of time to stave off those effects? Is that something
right?
like that?
Or even just making sure that that mother postpartum care in the United States is not very consistent and the greatest, given some health insurance coverage issues. And so, would that allow us to then argue we really need to be careful with these women, and we really need to make sure that they are covered in the postpartum period, so we can make sure that their blood pressure is under control and that they don't flip from having some temporary condition while they're pregnant to having sort of an ongoing long-term exposure to hypertension. Yeah, so then we would be able to develop new ways to intervene for them.
Right. And it sounds like possibly inform new policies.
Yes, which is really important.
Yeah, it sounds like it. Okay, thank you very much, Dr. Beth Shaaban.
Thank you.